First, let's read problem number 6. There were 595 tickets purchased for a football game. The lower stadium tickets cost $9.50 and the upper box tickets cost $10. The total amount of money collected was $5,751.50. How many of each type of ticket were purchased? So first we want to define our variables. We're looking for lower and upper box seats. And I like to just write an L and a U, so when you're writing the equations, it's easy to know which one is which. So I'm going to say L is the number of lower stadium tickets. And U is going to be the number of upper stadium tickets. So if we add our lower tickets plus our upper tickets, that is going to be a total of 595 tickets. For the second equation, since we have two variables, we need to have two equations to be able to solve this. So for the upper tickets, we're going to, for the second equation, we're going to see how much money for each piece, okay? So the lower stadium tickets cost $9.50. So $9.50 times how many lower tickets will give us the amount of money given by the lower tickets, and $10 times the upper tickets will give us the total amount of money collected for the upper tickets, for a total of $5,751.50. Okay, so what we need to do is we need to multiply the top one by a number to eliminate one of the variables. So if I times this top one by a negative $9.50, I will get negative 950L minus 950U, and that will equal $5,652.50. So we're going to add these equations together. I get 0.5U, the lower tickets cancel out, and 5,751.50 minus 5,652.50 is equal to 99. So if I take 99 and divide it by 0.5, I get 198 upper tickets. And then to find the lower number tickets, I'm going to look back at my very first equation. I know the lower tickets plus the upper tickets equal 595. So if I substitute this 198 back into 595, or in for the U, we're going to have our lower tickets equals 190. Our lower tickets plus 198 equals 595 minus 198 from 595, and we get 397 tickets for the lower and 198 for the upper tickets. On problem 2, the nut company charges $7 a pound for almonds and $6 a pound for peanuts. How much of each type should be used to make a 20-pound mix that sells for $6.30 a pound? Well, let's say that we have A is going to stand for the pounds of almonds, and P stands for the pounds of peanuts. If I add my almonds plus my peanuts together, that's going to give me 20 total pounds. Now we want to put all of them in terms of money. So if I take $7 times how many pounds of almonds, that will give me the amount of money for the almonds, plus $6 times how many pounds of peanuts, that will give me the total amount of money given for the peanuts. Now all together we want to have that 20 pounds of nuts to be a total of $6.30 a pound. If I times 20 times 630, I get $126 for the two different types of nuts altogether. So this is our $7 times how many almonds plus $6 times how many peanuts will be a total of $126. Now we're going to use elimination to solve. I can either times by a 6 or a -6 or a -7. Both of them will work. I like to times by the smaller number and then I get all positive numbers, but either one is fine. And I get A equals 6 pounds. Well, if there's all together, there's 20 pounds of almonds plus peanuts. I'm going to take 20 and minus my 6, and my peanuts will equal 14 pounds, where my almonds are 6 pounds of almonds. For number 8, we're going to use an equation that you probably learned a long time ago. It's distance equals rate times time. So if you, for example, if you had, if you were going 20 miles per hour, and you times that, you went for 3 hours, you would multiply these together and that would give you a distance of 60 miles. You multiply the rate times the time to get what the distance is. Now we're going to do it with planes. We're going to make 2 equations. The first one, it took 4 hours. That would be our time to fly 1,200 miles. That would be our distance. And we're trying to find the rate. Now the rate of the plane is going against the headwind. So our plane minus our wind. So that will be our rate. Our plane speed minus our wind speed will be the rate here. The return trip is going to be the same amount of distance. So we'll have 1,200 equals, but this is, the plane is flying with the wind. So the plane and the wind are going in the same direction, and the wind ends up pushing the plane. So let's have the plane plus the wind times 3 hours for that second one. Now, if I take that first equation, 1,200 equals P minus W times 4. What I could do is I could take that 4 and times it through. However, on the second one, I'm going to get a 3 and times it through, and then we're going to have to times by bigger numbers. An easier way, since P minus W and P plus W are set up really nice for elimination, if I take and divide this 4 out and divide this 3 out, it'll be really nice, and we can just add these together and the W's will eliminate. So I'm just going to divide both sides by 4, and I get 300 equals P minus W. If I take my 1,200 equals P plus W times 3, I'm going to divide both sides by 3, and I'll get 400 equals P plus W. Now, when I add these two together, the W's eliminate. I get 2P equals 700. Divide it by 2, and my plane speed is going to equal 300. Now, I have this, sorry, not 300, 350. Now, I have this equation here where my plane speed plus my wind speed equals 400. So if I know that my plane speed is 350, if I add 50, that will equal the 400. So my wind speed is going to equal 50 miles per hour when my plane speed is 350 miles per hour.